good afternoon. Welcome to one more lecture 21 of the systems engineering course. Today we are going to discuss about one important tool that is used in the functional analysis step of the systems engineering, which we call it as quality function deployment. At this point of time, again a quick recap. We were going through the three cycles, which is the one is the requirement analysis, then the next one was the functional analysis, and then design synthesis, and we had requirement analysis to the functional analysis as the requirement loop, and then functional analysis to design synthesis and back as the design loop, and we had the verification loop like this. And we are currently at this place, and we have already seen few tools and some like functional flow block diagrams, FFBD and stuff like that. So we are seeing another tool today called QFD, which is applicable in the functional analysis, called as quality function deployment, and it's an important tool in the systems engineering process. So what is the QFD? So we need to understand a little bit of history of QFD. It's a tool that the systems engineering adopted very well from the manufacturing side. A lot of this credit actually goes to the Japanese manufacturing industry. Developed by Mizuno of Tokyo Institute of Technology and first applied in the Mitsubishi Heavy Industries in Japan. So this was actually developed as a tool to quantify the customer expectations and or customer requirements, and then develop products according to it. So the QFD was envisioned as a tool that can be used to develop a product, in our case, or a system that can satisfy customer requirements, or we can call it as needs or specific specs, etc. So it was envisioned as a tool that can be used to develop a product. The initial version of this was developed for product manufacturing side, automotive and shipbuilding, those kind of things. And later it got approved, migrated to systems engineering. But the main aim, it's a tool that can satisfy, that can be used to satisfy customer requirements, so that the final design of the product or a system can satisfy the customer requirements. The first major product you can think about as a system also, because an automobile can be considered as a system. Through QFD, quality function deployment, was the Toyota minivan, and it went to become a big, a very popular product in the world. And it had like a lot of the customer requirements who actually are avid users of minivans. A lot of their requirements were satisfied as part of this. So hence QFD is thus considered to be applicable to all manufacturing or service industry. So the origins, QFD originated from manufacturing industry. Okay. Later adopted by systems engineering group, okay, or systems engineering people. So it's a planning tool. Again, it's a planning tool that is very planning of functions or functional design of the product, functional design of the system. Okay. When you are planning the functional design of the system, when you are planning the system functions, this is a really good tool that you can use to fulfill the expectations of the customer. Okay. We will see what the tools are and other details in the following slides. So, what is QFD? Okay. The simple definition, or in a way the best way to describe it is first a disciplined approach. Remember, systems engineering is a disciplined approach to develop complex systems of systems or system of systems, SOS. Okay. So, similar way, QFD, it's a disciplined approach to product design, where you are designing a product, engineering it and then producing it, allowing for in-depth evaluation of a product. So, it actually helps you in evaluation, in-depth evaluation of the design of the product, the engineering of the product and the manufacturing of the product. Same way, in our case, it is a instead of the product, if you replace this with system, it is a disciplined approach in systems design, engineering of the system, and instead of production you can say development, instead of development let us call it as manufacturing, or manufacturing of the system. Okay. This also QFD becomes extremely applicable to the field of systems engineering. So, in the expectations, what we call as customer specifications, or what we call in systems engineering as customer requirements or customer specifications or customer expectations. There are many ways people describe this aspect of customer specifications, about the view of the system, how the system should be, all those aspects. Okay. It is referred to as voice of the customer in QFD. So, in the QFD, the tool, the quality function deployment tool, the voice of the customer, whenever you mention here that phrase voice of the customer, it is exactly the same as the customer specification or customer requirements or customer expectations. These are all one and the same. Okay. So, here the main important things that if you think about it, this is where the parallelism with the functional analysis comes into picture. What are the qualities the customer desires? So, what are the qualities you can think about in the system that the customer desires? Okay. What are the qualities that the customer is looking for? What functions must the product, instead of the product you can think about it as a system. What functions must the system serve, and what functions must we use to provide the product or service, or in this case you can say system is the right way to look at it. Okay. So, this is why this gets applicable in the functional analysis. So, what functions must the system serve and what functions must be used? Okay. You can think about it as be used to provide the system or to develop the system. Okay. So, these things becomes a very important question of a functional analysis. And the third part, based on the available resources, how can we best provide what the customer wants? This is where the trade-offs comes into picture, trade-offs and capabilities. This translates directly to what we call as the alternatives. How best can we provide, or how best can we satisfy? The question is, how best can the customer needs be satisfied with whatever is available. So, this is also the aspect of it. Hence, this is why QFD is you can think about QFD as a best fit in the functional analysis aspect of a systems engineering or system development. Now, if you look at it, the customer voice, okay, Whenever you hear the voice of the customer, whenever anybody mentions voice of the customer, or in systems engineering parlance, it is the customer requirements, or other word is customer expectations. Whatever the phrase that we use in this case, the customer voices or the customer requirements or the voice of the customer or expectations, they can be in the following 6 forms. Number 1, solicited information. Number 2, unsolicited information. Number 3, quantitative. Number 4, qualitative. Number 5, structured. And number 6, random. So, solicited information is, if you think about it, number 1 is information that was asked for. Okay. So, you conduct different mechanisms like focus groups, surveys, interviews, field visits, etc., and then ask the customer, especially information, what do they want. Okay. One of the example videos that we seen in this class also a form of a solicited customer information. This is typically on an average about you can say 80 to 85% of the information that is required in the design of a system comes through what we call as solicited information. And number 2, what we call as unsolicited information. This is information that was provided by the customer in free will, okay, without being asked for. So, the customer gave this information without being asked for it. The customer was okay with sharing this information and go away from that. So, like many certain times the people who are actually like you can say that this usually happens in the case of like many of the consumer products, where the marketing executives, they will actually find people who are using the product, and sometimes somebody will share this information saying that okay, this is actually a problem, and then people will actually get to know about it and then use it accordingly. Okay. So, one of the classic example of this is the in India, the popcorn chicken rice that was made by KFC, where one of the customer actually went and provided this unsolicited information to KFC saying that why can't you have the rice, the vegetable rice that you make, and then mix popcorn along with it and add a little bit of sauce and sell it as a popcorn chicken rice. And nobody asked for it, and KFC felt that okay, this is a good idea, and they came up with a new product and became quite successful. So, sometimes unsolicited information also is a good way of getting aspects for product or a system design. You can think about some of this varies between 5 to 8% typically of a system. Okay. Then there are things like qualitative information and quantitative information. So, 3 and 4 okay, are again can be sought or provided voluntarily, but expressed in quantitative or qualitative terms. So, one person saying that okay, I want to have a soft touch leather as the seat cover in the car, that is a qualitative information, sorry. And a quantitative information would be somebody saying that okay, 0 to 100 in 3 seconds, 0 to 100 kilometer per hour in 3 seconds is what the acceleration I require. That would be a quantitative information. So, quantitative would be things that can be quantified, numerically quantified. It is also easily variable. easily verifiable. Whereas qualitative sometimes is like preferences. Okay. This is not really, sometimes you cannot really put a numerical value to it. That is the trick part of it. Then comes the 5, which is a structured information, and the structured information is an interesting type of an information because it can actually result in most of the time this follows a questionnaire or a series of structured interviews, etc. So, like sometimes when a new product is built, what happens is it is actually given to a limited set of users, and people who are experts in using the system are basically asked to try the system, and then a feedback is collected, and based on the feedback a structured analysis of the system is conducted. This is also an important aspect because sometimes this is the internal customers, a lot of the time the internal customers of a system provides this input in the structured information. Then comes the random information, which is like what you call as the unknown source and unplanned information. So, one of the big classical example of this is the usage of crash guards, the metallic crash guards on four-wheelers in India on different metro cities. That big steel, chrome plated steel bar that many people attach, so that it prevents motorcycles and bicycles and cycle rickshaws hitting and denting the expensive bumpers of the car. That is what the idea was, and that was basically developed as an aftermarket accessory, which almost every person was doing it, buying it and using it. Then the car manufacturers themselves felt like, okay, why don't we provide as a standardized accessory, because this looks like almost everybody is using it. So then this was a random information that was available to them, and from which that was many of the car manufacturers currently in India provide that type of a crash guard as a standard accessory to the vehicle. But that the motivation or the information that was available to them was purely a random information from which this was developed and derived. So, what are the benefits of QFD? Why do we need to do QFD? That is the important question that we need to answer as part of this whole exercise. Why do we do QFD? What are the benefits? Okay. What are the advantages of doing QFD? Obviously, there are quite a lot of advantages. The first and foremost is the team involvement and commitment at the design stage. We talked about multidisciplinary and interdisciplinary teams. Okay. The team involvement and commitment is because these multidisciplinary and interdisciplinary teams need to be involved at the beginning of even before the design of the product. Okay. The worst case scenario, they should at least be involved at the design stage. When the design of the product is begin, they should be involved. In our case, when the UAV was designed, during the time we were doing functional analysis itself, many of these multidisciplinary and interdisciplinary teams were actually involved and they were committed to the development of the UAV. So this QFD is a good tool that actually allows you to ensure the involvement of such teams. Then second part, the conflicts in both characteristics and requirements can be identified and addressed early in QFD. So sometimes you find out that there are some characteristics that the customer want and some of the requirements can be conflicting. And when you have conflicts, you have to identify conflicts and you have to address the conflicts. So like for example, is a customer would say the UAV would climb to an altitude at a very fast rate. That means the UAV should have a very high climb rate, so it should be able to fly fast. Then the person will also say that it should have a very high glide ratio. Normally both of them does not go together, they are both contradicting requirements. That's the point you have to say, well, which one of them is important to you? Is the glide is more important or the rapid climb is more important? When the customer says, well, rapid climb not that important of a thing. Well, we asked this question to our customers and they said, well, the most important thing is for us to maintain the high glide ratio, so that even if there something happens, we don't have too much of redundancy. So if it has a high glide ratio, we can bring the UAV back to our home. So the high glide ratio is important. So then, okay, fine, based on which the wing was designed, then we said, okay, this is the maximum rate at which it can climb, and the customer was okay with it, and that's so. Even before the product was designed, this conflict was identified and addressed, so that we did not even, once the product was designed, then this we would have wasted money and time if we did not catch it at the early phase. Third one is, it helps to identify new technology and functions to carry out operations and deliver a quality product. So the idea is that we can, the new technology options, we already said from requirement analysis as well as functional analysis, new technology identification is a critical aspect of any system development, and QFD allows you to identify new technology and as well as new functions that the system should carry out to deliver the, or to meet the customer expectations. When you say deliver the quality product, that means it is like meeting customer requirements. When we talk about quality, we can say that in a way it is actually meeting the customer expectations, is in a way to say that's the quality of the product. Then the fourth aspect of it is the reduce, redesign and modifications, thus reducing the time to deployment of the system. So if you identify and reduce and address many of the conflicts, and as well as in characteristics, requirements, and as well as performance parameters and stuff like that, when you can identify them the early itself, you are reducing the redesign and modifications to the system development. So hence the time to the deployment of the system can be significantly reduced. To a large extent, many of the system designs fails. So you can say that many designs fail due to inability to identify what? Conflicts at the early stage. Because once the product is built, the processes are there, it's quite hard to address these. So this is very important. So this is where this most important word called trade-off. Okay. So trade-off analysis among alternatives is a key criteria in this case. So the trade-off are made in design, okay, the design phase itself. So this kind of a trade-offs are called strategic trade-offs. Okay. So these are the long-term, okay, vision. So the strategy is the long-term vision rather than in the time of deployment. So you deploy the system and say, oh, there's a problem, now we need to deal with this and we need to make a trade-off. So such ones are called as tactic, because these are short-term vision. So the QFD allows you to make strategic trade-offs rather than tactic trade-offs. So the trade-offs that are made at the time of design itself rather than that are made at the time of deployment. Then we talk about improving the customer satisfaction. Obviously, yes, the quality of more the customer satisfaction, more the customer is satisfied with the system, more the perception of quality is. If the customer is satisfied with the system sufficiently well, then there's the perception of quality is also pretty high. Then last part is shorter development cycles. We saw that systems engineering process aims to shorten development cycles. So in this regard, QFD is a good tool that allows the systems engineering or systems engineer to control the development cycle and actually reduce the time required to develop the product. Okay. So, QFD has actually a visual planning matrix. It is again to an extent people call it as a graphical and a numerical tool. So, I usually call it as a graphical plus numerical tool. We will be sharing a case of QFD, the usage of QFD in designing a automotive system, which will be as part of the reading assignment in this course. So, you will understand how QFD can be used and used for product planning, and which to an extent you can extend it to the systems planning. So, this visual planning matrix is typically known as house of quality. So, somebody says a house of quality, I am doing a house using a house of quality tool or diagram to do the product design. That means they are using a quality function deployment. And what does this links? This QFD, this visual planning matrix, the VPM, the visual planning matrix, it basically links it is the visual planning matrix. The visual planning matrix links the customer requirements, the design requirements, target values, competitive performance. So, all these four are linked together as various functional aspects of the system. So, whatever the customer want, it is linked with the design requirements. So, this would be whatever the customer required, this would be some of the design requirement. Let us say for example, if you say I am following a mill 230 standard or something like that, then that particular standard, that is a design requirement of that. Certain target values are required. So, how to achieve the target values and what is the competition doing. So, if you are building a fighter aircraft, fighter jet, like lot of the a classic example of this is the Eurofighter Typhoon and the Dassault Rafale. You can see how these two systems, which are these two fifth generation, it's called as the fifth, they wanted to make a fifth generation fighters. Some people called as 4.5 generation. We can argue on that, we are not going to worry about it. But these two cases, if you compare, then you can find that how the competitive performance, how when the Dassault were developing Rafale and the Eurofighter, the other consortium of European Union countries were trying to develop the Typhoon, how they actually compare, how they compared with each other and tried to outsmart each other. That's the competitive, the performance of the competitor was taken into account. So, this allows for incorporating or exceeding characteristics of competing systems. This is another important aspect of the visual planning matrix, or what we call as the QFD aspect. So, how is the QFD process happens? So, this is a 7-step process, and the 7-step process allows you to actually build QFD, or what we call as a house of quality. So, the output of this QFD process, the output will be the visual planning matrix, or some people call it as a diagram, or the simple way to do it is the house of quality. So, you will have a diagrammatic tool that allows you to compare, allows you to link customer requirements, and as well as it allows you to link the design requirements, it allows you to incorporate target values, and it allows you also to merge in competitor information into this, so that the final design of the system will actually meet or exceed the customer requirements. So, the QFD process, the first thing is you have to do the product planning. Instead of the product planning, let us think about it as system planning. So, you start with the voice of the customer, or you start with what we call as the customer requirements. You take the requirements of the customer, and from there you actually start planning for the system, the development of the system. And within this customer requirements, you have to prioritize and weigh the voice of the customer. So, assign importance to appropriate customer requirements. Okay. So, the customer will have 100 different requirements, but you have to prioritize and weigh them according to what do you think as the best option available at this point. Okay. Then once it is done, you have to do competitive evaluation, or you have to benchmark. You have to benchmark the system with existing system, or you have to benchmark, if there is no existing system is available, you have to benchmark against something, or something like the benchmark against the target values, or benchmark against what the customer was expecting and how far you are able to achieve what the customer was expecting, something like that. Then once the competitive evaluation is done, when the system is benchmarked, this is where the system is benchmarked, then we let into the development of the design, or you look at the design of the system, where the primary question we say is what capabilities do we have. Then what capabilities do we have in designing and developing the system. This is the most important question that we have to do. Okay. Then the second that part, once you have established, okay, these are the capabilities we have, we do not have these capabilities, then the obvious question is, do we need to take and build these capabilities, or do we need to go do something else. Okay. Then once you have, okay, we understand these are our capabilities, then how do our capabilities match the customer needs. Okay. So, the actual design is how to match, it is a matching of the capabilities of the organization that is doing the system design with the customer needs. That is where the design comes into picture. Okay. And sometimes when you say find out that, okay, we do not have that capabilities, then what trade-offs do we make in the design. Okay. This is where how to make trade-offs in the system design. This is also another important aspect of this. Once this is done, or once all these 6 steps are done and you have satisfactorily answered all these questions and everything, then you can think about the planning of the process. Okay. So, you say, okay, fine, we now identify these are the most important things that we need to plan for, and these processes, or in another way you can think about it as function, these are the key functions that we need to ensure that the system should be capable of performing. So, these functions will ensure that the system will meet the customer requirements, or in this case what we call as voice of the customer. Okay. Now, finally, we just look into how this house of quality or the planning matrix, how does it looks like. So, it is a tool, this is why it is kind of told as a house, because you can kind of see kind of this portion, this specific portion gives this the idea of like a house. Okay. That is why people call it as house of quality. But the first and foremost, the customer requirements goes here. This is where the customer requirements, each one of the customer requirements are listed here one after another. Okay. And the technical requirements, the design requirements are listed here one after another in this area. Okay. Then both of these kind of things, between this is where we will be able to create what we call as the interrelationship matrix. The customer requirements and its relationship with technical and design requirements, and also what we call as another one is the planning matrix or customer perception, because this is where we will put appropriate perception of what customer thinks about each and every customer requirements. So, when you put a perception value here like 4, 3 or something like that on a different scale, once you establish whatever it is, then we know what is customer perception against that particular requirement. Okay. And what is the technical requirements or technical design requirements. So, if the customer perception is way much lower than the technical requirements, then you know what you are, there is a task of you educating the customer that, okay, fine, the customer might at some point of time, customer might in India might say that, why do I need a seat belt? And many of the automotive vehicles in India does not have, or the small cars does not have an airbag. Because people are like, oh, we are not going to drive it very fast. But if you look at the people who actually lose their lives in accidents, a lot of them are these small car drivers. So the customer's perception of safety for a small car or a compact car might be completely different, and hence when you say that, okay, I'm adding all these airbags and safety belts and pre-tensioners, electronic brake distribution systems, ABS, all those kind of things, then the customer says, I'm not willing to pay for this because I don't want this. My perception of safety is much different compared to your perception of safety. So that actually helps here. Then also these three things, the prioritization of the requirements, the competitive benchmarks, what our competitors are doing in this particular case against each of the technical requirements, and the technical targets, what do you finally target out of it, is also a part of this entire process. Similarly, the technical correlation metrics, it allows you to correlate between the each individual technical or design requirements with that of the other requirements. So this is where you can actually correlate one of the requirements with another. So this also allows for one of the famous things that we told about, grouping, identifying the specific functional groupings. That is also an important aspect of the system design. So with this today we will conclude, and you will all get a case that you need to read, and that case is very well explaining how this process goes through in a simple case of design and development of an automotive system, especially just a door, the passenger side door of a car, how is it built, and how the QFD function was useful in identifying what are the technical requirements and how the voice of the customer was built into this. And then you will understand how it is, and a lot of the time for each individual components or the major, at least for the major system components, QFD is used. Okay. So I would request you guys to go through that, and then based on and using the information that is provided, I think all of you would be able to understand the tool. It's a simple graphical tool, and we will continue to, I'll continue to expose you guys to more tools in the following lecture to come. Until that time, happy reading. Thank you.